Hi, my name is Michelle Brachman from IBM Research, and I'll be presenting our paper, Reliance and Automation for Human AI Collaborative Data Labeling Conflict Resolution. Our work is motivated by the need for labeled data for supervised and semi-supervised machine learning systems. Often this data is labeled by multiple humans to increase reliability, but if the labelers don't agree, then there's a conflict. And the hardest conflicts often need to be resolved by humans because they're on the boundaries, but easier conflicts may be able to be resolved in more automated ways. So our goal in this work was to understand whether human AI collaboration could improve the efficiency and accuracy of conflict resolution compared to humans resolving all of the conflicts manually. And we did this by combining automated approaches with human approaches in a conflict resolution tool. We used that tool to explore the impact of different types of information and the ability to resolve groups of conflicts as opposed to having to resolve all of the conflicts manually. First, I will talk through our conflict resolution tool and the variations that we used in this study. The default mode in our tool is manual conflict resolution, in which users see an individual data item like you can see here. We show an example of a short text data item from our study, but this tool could also be used for other types of data like images. So in this example, our data item is, who do I contact to change my contract from my old phone to my new phone? And the goal of the user here is to select the label that fits this data item best. For each data item, users can see the labels that were selected by the original set of labelers. And to manually resolve one of these conflicts, they can choose one of the labels and click Next. We had two types of information that we provided, depending on the condition of the user. The first was the percentage of labelers who picked each of the labels, and the second is the AI predicted probability of each of the labels. Depending on the condition, users saw one of these types of information or both of these types of information. Our data items were grouped either by the labeler agreement, AI predicted probability, or a combination. We provided these groups to signify to the users which conflicts might be simpler or more challenging. For example, a conflict with a lower labeler agreement might be more challenging, whereas one where more of the labelers agreed and had a higher labeler agreement might be easier to resolve. Users could choose which group they wanted to work on. Half of the users had the option to choose to review a group manually or to resolve a whole group at once, while the other half could only choose to resolve conflicts individually one by one. If a user chose to resolve a group of conflicts, they had the option to review the data and labels that would be applied before confirming. Depending on which information they had available, participants could either resolve using labeler's top choice or AI's top prediction, or they could choose between them. Using this tool, we ran a between-subject study to understand when and why users trust human labels and/or AI predictions to resolve groups of conflicts. We ran our study using Amazon Mechanical Turk. We provided bonuses based on a combination of time and accuracy. And our goal here was really to try to motivate users to balance these two constraints, because in a real conflict resolution context, the person would probably be busy, so they have a limited amount of time to resolve the conflicts, but they also really need high accuracy because otherwise you risk the negative impacts that poor data labeling could have on a machine learning algorithm. Participants' goal in the study was to resolve 100 data labeling conflicts, and afterward they completed a survey where they responded about their choices in using group resolve or manual resolve. So we had three research questions. First, how do automation and labeler AI information affect accuracy over time, and accuracy? Second, how do users rely on labelers, AI predictions, and the combination of labelers and AI predictions for conflict resolution? And third, how do users decide whether to rely on automated conflict resolution? We found that participants who had the choice between manual or group resolve had significantly higher accuracy over time than those with only manual resolution. This difference was primarily impacted by time, with no significant difference in accuracy. So basically what this means is that when users could choose to resolve whole sets of conflicts at once, they were faster without having lower accuracy, even though they were using an automated approach. Next, we wanted to understand how users relied on labeler and AI predictions for conflict resolution. And somewhat surprisingly, we didn't find a difference in the use of group resolve depending on whether users had information about human labeler choices, AI predictions, or both. However, those with only the labeler information did resolve fewer conflicts manually than those who had AI information. This meant that they resolved more conflicts using the group resolve, which may have led to over-reliance on the system. Finally, we wanted to better understand how users chose to rely on group resolve. Participants used a combination of system information and their own preferences. For example, they checked the high-level performance of the system, such as the percentages of labelers or the confidence of the AI, and they also checked individual items manually and in the groups to make decisions. Some of their choices were also based on their own confidence, which was heightened after more use of the system, and also their general perceptions of whether they should trust the system. Based on these results, we made suggestions for future systems. Our results indicate that participants can often make informed decisions about how to use automation, based on the fact that participants who had the choice between manual and group resolution were faster without a loss in accuracy. And we also found that participants were more likely to manually resolve conflicts in groups with lower labeler or AI confidence and use group resolve in cases with higher labeler agreement or AI accuracy. However, not all of the participants were successful in making effective decisions and likely need more support in choosing how and when to use manual and group conflict resolution. We also found that participants often wanted to check conflicts in group resolution before applying them, or hedge to make sure that the automation that they were using was going to work correctly. And our study groups were primarily small, less than 50 data items. But imagine a case with much more data. Users would likely need to evaluate groups of conflicts in ways other than checking each item individually, such as interactive approaches that allow users to interact with large groups in order to check them in a more efficient way. Thank you so much for listening, and we hope you'll reach out to us with questions or to discuss more on these topics.